All right. Okay, forgive my very minimalist slides. Did this at the last minute, of course. But thank you for coming, and I'm happy to share this little project that I honestly haven't thought about in 3 years until Sunny called me up and he's like, come talk. And I was like, I think I probably have something awesome and transit related. So about me, my name's Chris Whong. I'm senior developer evangelist at Mapbox. So I work on the Mapbox documentation and then blog posts, videos, and resources to help you be successful with Mapbox if you're a developer. And I'm also an educator, so I teach web mapping at NYU, not here, but over at Wagner. If you're looking for an elective and you happen to be at NYU, you can cross enroll in my class, which starts tomorrow night. I've been an outreach engineer and a solutions architect and a solutions engineer. I'm an urban planner by training, but also did some time working for city government, getting to build really fun, interactive, sorry, not just fun, helpful, useful, interactive maps. If you ever use Zola by New York City Department of City Planning, I founded the team that built the new version of that back in like 2019 and got to work on some really fascinating data projects in my short time in government. So I'm going to tell you about Subwaysheds, but first I want to talk about the inspiration for Subwaysheds. So if you go check out Chrono Trains, let's see if we can zoom in on it. So if you go to the main Chrono Trains website now, that's actually got an actual like trip finder and helps you as like a travel app. But the original Chrono Trains is this, which was how far can you go by train in 5 hours or some other number of hours in Europe. And a kind of really interesting use case that this developer, who's actually a former Mapboxer, came up with, which is as you move the mouse, once you get over a new city that has a train station, it'll just paint this isochrone on the map to show you how far you could get. So this was like addictive. I think it went viral. And when I saw it, my immediate reaction was, someone should build this for New York City. So I immediately started thinking, how can I do that? And I started building it. So this is a lot of fun. You should go play with it. It's actually old.chronotrains.com. And you can see kind of what they're going for here. The area that's most accessible is the closest train stations, obviously, and they're in dark, like in orange. And then the circles get lighter and smaller as you move outward. But this is pretty wild. So you can kind of see, when you're in a place like, a central place like Paris, you have a lot more reach within 5 hours than you are if you're in the countryside somewhere. So check that out. Let's go back to my presentation. Did I lose it? Okay, so what did I build? I built NYC Subwaysheds. I shouldn't have come back here. I should have just gone to the app. Okay, so here it is. Let's zoom in so you can see it. So again, the exact same premise. I kind of just rebuilt what he had in mind and said, what if it did it for NYC? So as you hover, let's reload. As you hover, oh, sorry, I built in locking. So if you just land on it, as you hover over a station and you'll see the isochrone changes. And you can kind of see, let's go to where we are now, for example, if we get on to Metro Tech, where's Metro Tech? I guess, yeah, right there. And let's click on the station to lock it in. And now we can zoom out and we can see, wow, within 40 minutes of Metro Tech, we have a large chunk of Manhattan, a little bit into Queens, and a very large chunk of Brooklyn. So that's it. So I'll tell you a little bit more about the technology behind it. It's a fun story. I'm going to do a little live coding demo to show you how the GeoJSON processing works. But the rest I can say about the front end, actually, I'll save that for later. So let's jump in on the rest of my presentation. That was awkward. Thanks for the chuckle. Okay. So starting with the data, right? So the very first problem was, how are we going to visualize travel time from each individual station? So I need to basically make the same pattern 490 whatever times, however many stations there are. So I started with a whole separate data project before I even started making anything visual on the front end. So this is NYC Subway Isochrones, which is a GitHub repo that's still up if you want to go check it out. But basically we start with GTFS data, which I'm sure everyone here is familiar with. Then I need to calculate the time from each station to each other station. And there's actually an R package that made that really, really easy. So I just installed the R package and said, it's actually meant to be a router for like routing applications, but I just wanted all the routes at once and said, okay, start with this station and then calculate the actual number of minutes to every other station. And then once I had that, I can start turning into something visual. So Yeah, the initial calculation done with GTFS data is done in R. And then I use node scripts using turf.js to turn each one of those destination stations into a buffer. And this is a naive way to say how far you can walk after you get out of the station. So effectively, sorry, let me see if I have a slide for this. Yeah, so we process the data in R. So the package is called GTFS router. So you should go check it out. It'll, in a few seconds, it can calculate all the travel times between each of the stations. Some of you are probably asking, what time did you say to start this trip? And I have no idea, but it's probably in the code. So I think I probably picked a weekday morning or something like that. But if you find out, send me a message and let me know because I can't remember. This was like 3 years ago. Okay. So here's again, these two slides are my algorithm slides. So this is kind of the process. Once we have a travel timetable for a station, so that's basically the travel time to get to every other station from that station, we section each one of those travel times into 10-minute, 20-minute, 30-minute, and 40-minute chunks because those are the 4 different breakups that I want to visualize them on by different shades. Everything after 40 minutes is not included in the visualization because it is not accessible within 40 minutes. So we throw those out. And then we do a bunch of spatial processing to buffer. So walking time left after the subway trip. So if we know that the station is within 10 minutes and we know that the actual trip on the subway is 7 minutes, then we know there's 3 minutes left over to reach the 10-minute limit. And that's how we visualize the buffer. And that's based on, again, some reasonable number for how far you can walk in 3 minutes that I don't remember, but it's probably in my code. Then we dissolve all them together because otherwise they would all just be a bunch of separate circles. So you need to do a dissolve operation. This is like classic GIS. And then we intersect. So we're actually clipping it to the shoreline. So now I'm going to do a live demo. Oh, look, there it is. I made a slide. Live geoprocessing demo. So let's see if this works, just to kind of help demonstrate what is actually happening here and give you something fun to watch. So I've got some Node.js code here. Again, I probably did all this by hand because it was 3 years ago, right before AI coding took off, and AI probably would have done this in like 30 seconds, but it took me a weekend. But let's try it. Okay, so I've commented out where I dissolve the circles together. So I want to process one station. I actually have it set up to just process J Street Metro Tech. So I'm going to run that, and it's going to spit out an isochrone here. So this is A41. A41 is the code for J Street Metro Tech. If you've ever looked in the GTFS data, I bet you some of you knew that. Who knew that? Come on. Yeah, Sunny knew it. Okay. Okay, so let's open in Finder. I'm going to go to my old friend geojson.io so I can visualize this. And we're actually going to try the new geojson.io, which you all should try if you mess with geojson. And let's drag this in. Okay, so we have a whole lot of circles here. So again, I'm going to go step by step here so you can understand like how this all works. But basically, this is all the buffers without the dissolves, and this is for a single station. So we want to turn this into one. Basically, we want to turn it into four dissolved polygons: one for 10 minutes, one for 20 minutes, one for 30 minutes, one for 40 minutes. But if we click on any one of them, we can see this is a 20-minute duration. I don't even know what station this is, but it doesn't matter because I'm just going to show it on a map. It's really only there for visual purposes. So again, this looks really sloppy and ugly, but like we're starting to see something come out of that data that we got from the router. Let's go back and we'll uncomment this. So this will dissolve them together. So I have a function here called turf dissolve, but basically it's going to split them. Sorry, all the ones that are in the same cohort. So 10-minute, 20-minute, 30-minute, 40-minute, it'll dissolve them. And we should end up with four multi-polygons when this is done. Let's run that. And let's try it again. So let's go delete all these. Let's go bring it in again. So this is the new output. And there we go. So now we're seeing something closer to what was used in the visualization. But the only problem is now these are kind of bleeding out into the water. So we take a shapefile from New York City Open Data that has the shorelines of New York City. And I didn't test this one, so let's try and do it. So we'll say clipped FC. And then let's pass, I think we just call it FC. Sorry, I was hacking this just so I could run it in front of you. So let's see if it works. Run that. And again, I won't show you the gritty detail. Let's delete all of you, drag it back in. And now it is nicely clipped to the shoreline. And now it's ready for use in the app. So basically ran that process on for 490 some stations, whatever it was. And if you look at the front end code, which is all on GitHub, you'll see a directory full of these GeoJSON files. I'm not loading them all into the front end at once because they're pretty big. I probably could have made them smaller, but it works. So yeah, if we click on JStreet Metro Tech, this is actually the exact same GeoJSON that I just processed again in front of you. And we can see how far we can get. Okay, what's next? So for the front end app, this is pretty much my go-to stack when I'm coding. Obviously, we're using Mapbox GLJS, which gives us this kind of lightning fast, basically changing out the data in real time. So every time you hover over a new station, I'm actually fetching that data from my server and then swapping out the layer in the map that is presenting that data with new data. So it rapidly changes. Actually, it was running a little slower today, and I wonder why that is, but we'll see. I use Vite for my build system. I use React. I use Tailwind. There's probably lots of other things in there, but the code snippet I showed here is where the magic happens, where I'm just calling, I'm getting the source from the map and then calling set data on it with the new data that I retrieved. And there's a fetch right there. So that's all you got to do, and that worked. I should share, I was able to swipe a awesome open source React component for making subway signs from another project, which I have to give a shout out to. And if this person hasn't talked here yet, probably has, but that was NYC Guesser. So this person made a game where you reload and you get a subway stop. And I'm like, I have no idea where the Jay-Z is, but it's probably somewhere. Confirm. I wasn't, it could be better. Okay, so you reload and then Rego Park. Oh my God. Okay. I don't get out much. Okay, so anyway, he had a React component that already did all this stuff and had like symbols for all the subway stops. And I was like, I'm not building this from scratch. I'm just going to borrow it from him. So thank you for making that open source, Ben. And that's what you see in my app. Also, is just exactly the same subway shields or subway signs component that he shared. So that was a lot of fun. I gave him a shout out on Twitter or somewhere, and I think he was happy to see it get reused. And I think that's all I've got. So thank you. What do we do now? That's all up to questions.
How long did it take to compute all of the station-to-station travel times?
Again, this was 3 years ago, and once I got it working once, I just ran it as a batch. It probably took 5 minutes or something like that. I don't think it's doing a lot of calculations with the GTFS data, but because I think that package is pretty good at it. So I don't think it was like 1 second or anything like that per trip. It's a lot less than that.
Cool.
Yeah.
I'm curious why you chose 40 minutes as the travel time duration. I think in your source of inspiration it was like 1 hour.
Yeah. I don't think I have a good answer for that. I think I wanted no, I don't have a good answer for that. 1 hour would have been good, but I think it probably covered a lot and is a little more interesting when it's less. I don't know.
Thank you for the presentation. My question is, in your code, in terms of calculating the time difference of how far you can travel in 40 minutes, have you accounted? There's like 2 ways of calculating trips. One is like using the one trip that is closer to the time you were thinking of visiting the station and taking a trip from the station, and then the other part of the static GTFS potentially is written with like a frequency sort of idea in mind in the static GTFS component. And I'm wondering if I Frankenstein a code, adding a new line into the existing GTFS package, but with coding it based on frequency instead of how the MTA codes all of the static GTFS with individual trips?
Yeah.
Would your code base hypothetically still work?
I think, I don't know. I would assume that the R package can handle frequency related trips in GTFS, but I don't know for sure. So I would think it can. I would suspect that it would make its best guess, or just use the largest frequency to accommodate for it. But couldn't tell you. But I would love for you to try it out and let me know what happens.
No, thanks.
Hey, quick question. Would you be able to look at different times of day or different headways or different service interruptions and see how it changes?
So for this app, it's very static, right? So I did a lot of data processing ahead of time, and the only thing that goes into the app that you see is the output GeoJSON files. If you wanted to set it up so that you were doing this on the fly, absolutely. This is more of a this is more for fun and for general interest than it is for actual like transit planning. But yes, you could totally build a UI that says, I'm leaving at 4 p.m. on a Tuesday from this station. Tell me how far I can get. A lot more complex and a lot less front-endy.
Hey, Chris, this presentation was great, very
Thank you.
comprehensive. It was noon weekday.
Oh, you looked it up?
I looked at your about and your repo right before.
Great.
I will say it'll be fun to have AM peak and PM peak and
Yeah.
just recompute if you ever go back.
And that's why, so it's all static. So just the number of hosted files would get larger, but like we could totally do, that. Anyway, it's open source. I actually would love, if anyone wants to PR a little control and switch it and then run all the other data, that would be fun. I haven't touched this in a long time.
My question about the radius that you put on the circles.
Yes.
Like how did you decide on that? I assume it's some kind of heuristic about like how long it takes to walk.
I bet you we can find it right now. Buffer. Okay, here it is. I left a comment for future me. Leftover seconds to walk, 1.2 meters per second equals buffer distance.
Okay,
So-
cool. Yeah. So the first time I saw it, I thought like the land is not flat in New York. I live near Morningside Park, like huge cliff. I think about it. It's like
Yeah.
100 feet probably long, but I never cross it. Like, do you have any thoughts? Did you have any thoughts about like representing this not walkable
Yes.
kind of?
Absolutely. So that would have required a whole other routing system to create real isochrones based on walking. And that would have been a lot more time than the weekend I had to work on it or whatever. So yeah, I think if somebody wanted to spend more time on it, then yes, they could totally, instead of just doing a naive buffer, it's kind of cardinal sin of GIS people. So I'm sorry. But like, yeah, if you want to actually map it to the sidewalk network, then you would have a much better picture. But I think from like a 50,000 foot view, this gets the job done.
Hey, Chris, thank you for the presentation. I was wondering, do you have any more recent or other interesting projects you work on that you think would be interesting to highlight in this forum?
Nothing transit related. Probably the most notable side project was the NYC Public Space app, which I did last summer, which is now, I was telling Sunny, now have the problem of maintaining an app that a lot of people downloaded. So check it out. Anyway, I mushed together something I wanted to do when I was in city planning because I discovered all these new public data sets for different types of public spaces. So there's privately owned public space, there's parks, there's waterfront public access areas, which are a thing a lot of New Yorkers don't even know are an official designation. There are schoolyards to playgrounds, which is a whole program that makes schoolyards open to the public, but notoriously not well documented or not mapped. So I mushed them all together into one mobile app so you can kind of see all the public space kind of under the entire umbrella of government regulation. It's actually not in the App Store right now for iOS because I didn't pay my Apple dues, but it's still available for Android, and there's a web version if you want to check it out. That's probably the most interesting thing I can share.
You find yourself still using Subwaysheds or more the other project?
I bring it up every now and then for demos just to show, fun and interesting things you can do and kind of talk about the actual technical implementation of like introducing new data to the map over the network and like swapping out data on the map. So I'll bring it up every now and then, and I think some of them may share it every now and then on LinkedIn or whatever. So it comes up, and actually, the access tokens get stale, and like every time I load it, I'm like, oh, this thing still works, and like there's people using it, and I think it gives people some new information they didn't have before.
Thank you.
Okay. We have a question online from Sarah Sachs. Thank you so much. Curious if you might have analyzed patterns such as the most accessible neighborhoods or other ranking of the best connected subway cluster, or if the data set might be publicly accessible for others to analyze.
The data is all public, so you can go on my GitHub and you can download all of these isochrones, but all you have is the start station ID, so you don't really have much about the destination. And these are all, again, intended for visual analysis on a map. They're not really for data science. If you want to do the data science, you move back away from the visual stuff, and then you have the raw data. But like I said, anyone can generate that lookup table of how far away or how long it takes to get from each station to every other station. But all the CSVs that came out of that are also public on that repo I shared earlier. So the answer to the first question is no, I haven't done any actual analysis on it. This is a visual project.
Mm-hmm. Cool.
Right. Any final questions? Oh, there's one.
If we have time, I may have missed this. How are you loading the Mapbox layer? Is it like the map loads call?
Sorry, how am I loading?
The Mapbox, the visual layer. Do
you mean the actual isochrone layer?
Oh, not the isochrone layer, but the geospatial data at the back.
Are you talking about the subways?
No. So, for example, Hempstead, Valley Stream, all the layer of data. The base map. Yeah, sorry.
Yes, I believe this is the Mapbox dark style, but I've turned off. No, I haven't turned off. So yeah, it's just Mapbox dark is what it's called. So it's a dark style.
So every time a person visits it, does it call?
Yeah, so everything's rendered in the browser. So this is so Mapbox GLJS is it actually uses a canvas to paint the map every single frame like you would if you're doing a video game. So yes, it's downloading something called vector tiles. So there's probably 20 vector tiles or so that constitute this map. It downloads all of them and then renders them. So it's got all the data you need for streets and place names and things like that. And then I'm overlaying the subway stops, the subway stations, and the isochrones and this kind of outline of New York City's boundary. Those are all things that I added to the base map.
Thank you.
And since you brought it up, I think I brought it up here. I have a GitHub repo that actually has these layers on it for people that are making maps because I needed it so often for New York City based maps. So if you ever need subway lines and what to color them and subway stops, it's all here on this GitHub repo.
All right. There's one more.
Out of curiosity, how do you decide which stations to render labels for on the map?
Oh, I don't know. Let's go look. What did I do? I believe they are colliding. Yeah, so they're the technology uses collision detection. So the labels are another layer, and when they're going to collide with each other, it chooses which ones to hide. So you can actually apply higher weights to certain ones. This is how. If you zoom out on a map of New York City, it'll still say New York, but it won't say, downtown Brooklyn or whatever. So there's different weights associated with the different labels. And here, I think they're all the same. So it's just making some kind of algorithmic call. But if you zoom in, you'll see them all.
Thanks.
All right.
I think we got one more up here.
Oh,
nice.
Just to build on that, the layer for the subway lines, stops, and labels.
Yes.
So is that a GeoJSON layer or a tileset layer?
It is a GeoJSON file. So you can actually open it right here under data. And here are the routes. And it'll preview on GitHub. Did it not? That's weird. Let's try that again. Huh. Okay. Anyway, trust me, it's GeoJSON. And then the stops are also, okay, it rendered the stops for some reason. I don't know why it didn't render the points. But yeah, they're GeoJSON, so you could download them. You could make them into vector tiles, but there's no reason for that because it's pretty small.
Thanks.